Okay, brothers and sisters, welcome to our Exam 2 review. We have a lot to cover tonight, but I'd like to open it up to see if anyone has any questions I can answer before we get going. Okay, good deal. If you have a question, feel free to just unmute yourself. Please speak up. You can use the chat. I've got that up and I can see it. Anyway, let's get started. So I'd just like to remind you a little bit about the format of the exam. Okay. I want to double check that I am sharing. Everyone can see my screen. So I snipped this from the beginning of the exam. These are things that are allowed during the exam and not allowed, right? So please feel free to use your textbook, right? Your textbook is a great resource for reference. W3 Schools, that one specific website is available for you to use. The open internet is not. So please keep your study materials that you have at hand limited to the textbook and W3 Schools. You're welcome to your HTML file template. The W3 HTML validator is also open to you. And then something like Visual Studio Code or Notepad++ or Sublime. Please don't, some of you work with family members who are programmers. Obviously not okay to have that kind of collaboration between family members during the exam, though it is okay during your assignments. And there's just a single attempt for the exam. The exam is composed of 20 questions. This exam is worth 15% of your final grade, just like exam number 1 is, with exam number 2 being worth 20% of your final grade. Those 20 questions are divided up into multiple choice, multiple answer, and a few short answer. The final 2 questions of the exam are programs that you need to write. Defining tables must accompany those programs. And yeah, that's basically all I have to say about the format and the rules for the exam. Are there any questions specific about that? Okay. Perfect. Like I say, if you have a question, please feel free to interrupt or raise the hand. Okay, so this exam does technically cover all of the principles that we've studied through the first 9 weeks of the course, but it is very heavy on the exam or on the topics that we have covered since our last exam. So you recall that we took our last exam during week 5. The topic of week 5 was variables in arithmetic. Since then, we've covered if statements, or in other words, the selection control structure. We've also covered Boolean logic, so your and, or, and not operators. And we've also, we're about 3/4 of the way through our study on repetition or loops. So you should expect some questions on the first 5 weeks, but it's going to be very heavy on the last 4 weeks, right? So a lot of selection, a lot of repetition, a lot of Boolean logic. So that's where I would like to focus our preparation tonight. And to do that, what I usually do is I go back through the reading, and then we'll do a couple practice problems. So I'm going to skip down to week 6, which was selection, right? Selection is another way of saying, programs that you wrote before week 6, all of the lines were executed sequentially, right? So sequence is another, or sequential is another control structure. Selection changes it. There are some lines that are executed and some lines that are not. You write code that selects which of the lines of code are executed in your program. And that's why we have the term selection. So there's a couple ways to do selection. We covered 2 if statements and switch statements. There are a couple other ways that you can achieve that. little bit beyond the scope of this course. But remember that you can have a single if statement, you can have an if-else statement, or you can have if, else statement, and then if statements can be nested. So you can have multiple if statements nested inside of each other, just like HTML elements. Okay, if statements are accompanied with the if keyword, right? So watch for those. That's a reserved word in JavaScript. You can never declare a variable called if, maybe in JavaScript, but not in more structured programming languages. They're always accompanied with a condition, right? We need to know the decision that the computer will make to select and execute the statements or skip and not execute the statements. That condition is always surrounded by parentheses, and then optionally we have curly brackets. If there's a single statement, curly brackets are not required. If there are multiple statements to be selected, curly brackets are required. Okay, so if this condition is true, then everything inside of curly brackets will be executed or selected for execution. If this condition is not true, none of these statements will be executed. None of them will be selected for execution. Okay, the else statement allows some decision to be made, right? Whether this condition is true or not. If this condition is true, this statement will be executed. If this condition is false, this statement inside of the else block will be executed. So you are guaranteed to get one or the other of these statements when you use an if-else, okay? A common mistake is students will say else, and then they'll type a set of parentheses and provide a condition. Else statements don't have any condition. They're just there as kind of a catch-all. If the if statements that precede it are not true, the else statement has no further requirements. Its only requirement is that this condition be not true. Okay. If statements can become as complex as the developer would like to make them. The way we do that is by adding many more conditions, right? And we do that by using an else if, right? Another way they could have written this is otherwise. If this condition is true, otherwise, if this condition is true, otherwise, then else finally is the catch-all, right? So else if statements, they have a space. There are some programming languages where this space is not required. It is required in JavaScript. And else if statements require a second condition, right? So they are ordered. The if statement will be checked first, and then the next else if statement will be checked if the if statement is false. If the if statement is true, then this conditional statement is done. Okay. The else block is optional. As you can see here, we've got if, else if, so there's no fallback condition, which makes sense, or it used to make sense for genders, right? Either they're male or they're female, and so forth. So do we have any questions about if, else, or else if statements? Perfect. Okay, another way to achieve this is with a switch statement. A switch statement only has, well, the condition is split up, right? We switch or we check a bunch of cases on a specific variable. The selection happens, we say if this variable meets this case, then the statements between this case and this break will be executed. If this case is false, then we will check the next case. If all of the cases are false, that's why we have this default block. It's very important to use the break statement. Otherwise, multiple conditions will be checked. And anything that you can write with a switch statement, you can write with an if statement, or vice versa. Anything that you can write with an if statement, you can write with a switch statement. And maybe we'll do that as we're doing our practice program down here. Okay, so I'm going to skip past all of these examples, and let's go down to our programming assignments. Okay. So I'm going to pick one that we didn't end up doing. I think we will probably write this one. So this program requires us to read in a student's name and number of completed university credits, and then outputs the student's name and year in school. So we've got some cases here. If the student is between 0 and 30 credits, they should be a freshman. Otherwise, if they're between 30 and 60, a sophomore, 60 and 90, a junior, 90 and above should be a senior. So we'll go ahead and write this program. For the sake of this video, we are going to skip the defining table. Defining tables are extremely important. Don't skip them in your assignments or your exam, but just for brevity tonight, we will be skipping that. Okay, so I've got my template HTML here. Before I begin, does anybody have any questions about this practice program that we're going to write? Okay, perfect. So let's go ahead and first off, we need to ask the user for their name and number of credits. So let's write that HTML. Okay, I see a question coming in on the chat. Oh, Chris is letting me know that maybe I did this on my week 6 video, which sounds right. I made those quite a while ago. So thank you, Chris. Let's go ahead and do a different program. Let's see. Let's do this one. A bank will not loan money to a home buyer unless the home buyer pays for part of the house at the time of purchase. This initial payment is called a down payment and is based upon the cost of the home. The Bank of Ryrie calculates down payments according to this schedule. So if the cost of the house is between 0 and just under $50,000, it's going to be 5% of the cost. Otherwise, if it's between these two marks, it will be $2,000 plus 10% of the cost less $50,000. So this is our hierarchy here. I'm going to go ahead and, because this is a little more complicated, we will keep those instructions up while we program. Let's go ahead and do it. So as I said, we can accomplish basically any of these things with an if statement or a switch statement. Let's go ahead and write it with an if statement first. Okay, I'm going to write it the complicated way and then simplify it. So very first, let's ask for the cost of the house. Okay, so I'm going to come in here. Okay, perfect. We'll add an HTML break tag. A button that says calculate. Give it a meaningful function name. Never underestimate the power of copy paste. Okay, so let's make sure this is all opening or appearing just exactly as we'd expect it to in Google Chrome. Perfect. Open Google Chrome Developer Tools, no errors. So let's keep programming. Okay. So we need to very first go get the cost of the home. I wonder how many times you've written this line of code, document.getElementById. Probably many, many times. Okay, and I'm going to introduce a bug here. Let me know when you see what the bug is. Okay, we've got the cost, so now we need to do a little bit of logic. we need to do logic on the cost. So we want to know if the cost is between $0 and $49,999. So we want to ask the question, is the cost greater than 0? And we probably want a greater than or equal to 0. Or if the cost is less than 50,000 and 0 cents. Okay. There's our first condition. As we said, it's between these two numbers. We need the cost to be 5% times cost. Okay, Chris has messaged me. He has identified the bug. I used the parse int function here. What I really need to do is use the parse float function. If I were to use parse int and I came over here and I typed in the cost of my house and I said it was $49,999 with 98 cents and I used parse float, even though this amount should be legal for the 5% down payment, we might get some rounding. It would round up to 50,000 and then we'd be paying quite a lot more down payment. So please, it's probably a good idea to just always use parse float unless you know you're not going to be working with floating point decimal numbers. Good job, Chris. Okay, so we've changed that. We've got our first set of logic here. If it's greater than or equal to 0, but less than 50,000, that's what we want. Okay, I'm going to leave that blank for now, and I'm going to come here and do our else if. And then I'm going to ask the question, else if cost is greater than or equal to 50,000. I think that's 500,000. 50,000. And, yep, that was a bug. And cost is less than 100,000. Let me do that. I'm actually going to copy this line because I'm a lazy programmer. And then I'm just going to change these numbers. So we've got to be greater than 100,000, but less than 200,000. Okay. Finally, what do you think? Should we use else here or else if?
Else.
Else, okay. Perfect. So we've got our 4 cases. Now we need to calculate the down payment. So let's create a new variable. Let's set it to 0 to start. I'm going to write this line of code before, well, no, I'm not. Let's use our console. So if the cost is between 0 and 50,000, what do we need to do? We need to calculate 5% of the cost. So we're simply going to take the payment and we're going to set it equal to cost times 0.05. And that should be the payment. For debugging purposes, I'm going to use a console.log payment. Let's go ahead and save our program, come back over here to our HTML, reload the page, and we should see if my house costs $10,000, 5% of that is 500. So my down payment should be 500. If I double it to 20,000, it'll be 1,000. If I make it 200,000, we shouldn't get any value because we haven't written any code for that yet. So good. The program appears to be working so far. All right, next, we want to, if it's between 50,000 and 100,000, we want to say the down payment needs to be $2,000 plus 10% of $50,000 less than the cost. So let's go ahead and write this. So we're going to say, first off, we need $2,000 plus 10% times cost minus 50,000. Okay. So let's go ahead and go back here. I have a house that's going to cost $75,000. So let's do some math here. It's going to be $2,000 plus 75,000 minus 50,000 is 25,000. 10% of that is 2,500. So I calculate 4,500. Does that sound right to everybody? Oops. Got a problem.
You didn't put a console log.
Oh, thank you. Very good, Gonzalo. Okay, reload our page. $75,000. There we go, 4,500. If we double it to $150,000, we should expect no output because we haven't written code for that. Okay, very good. So the down payment for between $100,000 and $200,000 is, we need to do payment is equal to $7,500 plus 20% times cost minus $100,000. And let's not forget our console.log. Back over here. Let's test out that case, $150,000. Okay, that makes sense. Yes, yes it does. $7,500 plus 2% of 50,000 would be 10,000. Yes, that's exactly right. Oh, math. Okay, now we determined that we are going to do this with an else. And we have basically, this case down here, we need to do 27,500 plus 25% of the total cost minus $200,000. So let's go ahead and code that up. $27,500 plus 25% times cost minus $200,000. Okay, and of course a console log. All right, let's come back here. Let's try our $250,000. Oh, 40,000 down. Okay, very good. I'll now come and do a document.get element by ID. We're looking for the output div. And we're going to set its inner HTML property equal to the payment. Let's get rid of these console.log lines. Okay, reload the program. Let's run through our cases again. So a house that costs $20,000, $1,000 down payment, a house that costs $75,000, $4,500 down payment, a house that costs $150,000, and a house that costs $250,000. Very good. Okay, it's not a very practical case, but we do have just one minor problem in this program. If I were to come in and type in a negative $100 down payment, who can predict what the down payment will be? So we got a down payment of negative $22,525. The reason we got that is because instead of using an else payment or else if statement, we used an else. So because a negative number is not greater than or equal to 0 and it doesn't meet any of these cases, any negative number will actually hit this else statement. So I think probably our best bet here is to do an else if and just say cost is greater than or equal to $250,000. So let's reload and try that again. Yeah, that makes more sense. It doesn't make a lot of sense to have a negative $100 down payment. Maybe back before the big housing crisis, I don't know. But yeah, here's our program. Does anyone have any questions about it? Okay. Very good. I'm going to save this code so that anyone who is watching, I'll put it in the chat for right now. And I will also send it out via email. I see I've missed some chat messages. Yes, Chris predicted. Good job, Chris. Okay, so we're going to go to everyone. I've pasted the code into the chat for anyone who cares. And like I said, I will save this for students who are watching the recording. Okay, so that was our lesson on selection. The next lesson up during chapter 7 was about Boolean logic. So let's go down to our chapter 7, reading logic, right? So whether you know it or not, you've been using logic for your entire life, right? When you were a little kid, you said, "Mom, I want some dessert." And mom would respond, "If you eat your dinner and clean your room, then you can have some dessert," or something like that, right? So right there, that was a Boolean statement for mom. There are two conditions to be met: eat dinner and clean room, and there's one Boolean operator, the and operator, right? So think about that in the coming days. Anytime you set a condition for anybody, you're doing Boolean logic, right? So the operators, the three operators I want you to focus on are not, and or. Exclusive or in JavaScript just doesn't make a lot of sense. There's one question on the exam that uses the exclusive or operator. And for as long as I've been teaching at BYU Idaho, I just give everybody full credit on this question, whether they answer it correctly or not. It's just not something that's you're going to use very often, ever. It's a binary operator. You have to be doing binary operations. You're probably not going to do that. If you are, you're not going to be using JavaScript. So again, focus on not, and or. Right? This is how we can make very complex conditions inside of our if statements. If you remember back to the programs for this week, right? You had a alarm clock program where you were going to either sleep in or wake up. And some of the conditions there, it had to be December and it had to be the 25th day of the month. Right? So there we used an and. Some of you grouped those statements together and only had the sleep in message once. And if you did that, you would have had a very complex Boolean statement where it was condition 1 and condition 2, or condition 3 and condition 4, right? So you would have used the and the or. So let's go through this. Really not a lot of content to this section. We did go over the advanced word search, truth tables. You used to have to fill out a truth table in the course, but I think it's an optional assignment now. Okay, and here we are at the programming assignments. Okay, so I don't remember which one I did in my weekly announcement videos a couple years back, but I know it wasn't this one. Yeah. Let's do this one. Write a defining table in a program that asks the user to enter a month name, January, February, etc., and then outputs the number of days in the month. For February, output 28 or 29 days. Okay, so who knows the nursery rhyme? Who can tell me the rhyme? I don't know it. I know the first line.
I think
30
we did
days.
this one, but Davidson, on your
Oh,
exam.
did we do this one in the example? That's, thank you. Thank you. Very good. Okay, let's do this one down here. Write a defining table and then a program that determines what time a child should go to bed. The program must read a child's age and the season from the keyboard and output the child's bedtime according to this table, right? So we've got some complex decisions to make here. If they're 5 or younger and it's summer or fall, then 8:30. If they're 5 or younger, then winter or spring, 8 p.m. Any questions about this program before we go write it? Okay, so I'm gonna go back, grab my HTML template. And here we go. So again, skipping the defining table for brevity, but please include defining tables when you do your programs. For some examples of defining tables, the exam 1 review video has a pretty good example there. Okay, so we've got some decisions to make here. We need to know the age and the season. So let's write some inputs to get that. Let's just copy this line. Okay, and then make the button say get bedtime. Okay. Perfect. All right, so let's write some code to go get our inputs. What do you think? Is this an appropriate use of parse int, or should we be using parse float? Okay, we've got our 2 inputs here. I'm going to create a variable for the bedtime. Hopefully we overwrite that. I'm also going to write to my output at the very beginning. Okay, let's crack this open. I'm going to say child's age is 8 and it is fall. Get bedtime, never. Okay, we are all set up to write some code. So let's do this. If the child's age is 5 or younger and it's summer or fall. So let's write that. If age is less than or equal to 5 and season is summer. I'm going to add a bug here, so go ahead and shout it out when you know what the bug is. The season is summer or fall, and we're going to set the bedtime equal to 8:30 p.m. Okay, who can see the bug? What is the bug here in the program so far?
It doesn't look like you repeated the variable adject with the fall. You just put the or.
Yes.
You've got to repeat the logic.
Very good. Thank you, Chris. Yes, we for people who don't speak computer, this is a completely valid question. Is the season summer or fall? But when we're talking to a computer, we have to be extremely explicit, and we have to say, is the season summer or is the season fall? Right? So just like Chris was saying, we need to repeat our Boolean condition, adding in the equality operator and a comparison to the season variable. Okay, very good. So let's go ahead and try this out. Reload our page. I'm going to say we've got a 4-year-old and it is summer, 8:30 p.m. However, a 4-year-old in the spring never goes to bed. Okay, very good. So coming back here to our code, I'm going to use an else if, and I'm going to copy this condition. And now I'm going to say if it is winter or spring, not spring, but spring, our bedtime should be 8 p.m. Okay, let's go take a look. So our child is 3 and it is winter, 8 p.m. Child is 3 in the fall, 8:30 p.m. Okay, so far so good. Okay, I think we have a bug here. I'm going to come back and I'm going to say that the child is 16 and it's fall. The bedtime should be 8:30. Let's refresh just to emphasize that. The child is 16 years old and it's fall. Their bedtime is 8:30. Well, how can this be, right? We haven't written anything. The condition here says that their age has to be less than or equal to 5, but the age was read in as 16, and we are supposed to go to bed at 8:30. So who can identify the bug here? Remember that Boolean operators have a precedence. Just like multiplication happens before addition, and just like division happens before subtraction, ands always happen before ors, right? So this is how the computer evaluates this statement. It comes in here and says, okay, and has a higher precedence. So I'm going to check if age is less than or equal to 5 and season is equal to summer. I'm going to check that very first. And that's either going to be true or false. In our case, it was false, right? Because the age was not less than or equal to 5. But then we could just replace this. The computer basically replaces this with false. And then it does this comparison. False, or is the season equal to fall? In this example, the season was equal to fall. So we got the 8:30 bedtime, even though a condition that we thought would be evaluated wasn't. So just remember that Boolean operators have a precedence, and just like mathematical operations, we can change the precedence, with a set of parentheses. So now the parentheses make this condition happen first. Is it summer or fall? Evaluate inside the parentheses first, and then come out here and ask the question, is age less than or equal to 5? It is not. And false and true is going to be false. So let's verify that we fixed the bug here. Never. Perfect. Okay, we have the same bug on line 14. Okay. Any questions about what I just did? Okay, let's go ahead and add all of these other cases. Okay, so get a copy pasta going here. The next case is 6 to 12. Age is greater than 5 and probably or, nope, and age is less than or equal to 12. And the season is summer. Then the bedtime should be 9:30. Okay, let's copy paste again. If it's greater than 5 or less than 12, and here I could type out season is equal to winter, or season is equal to spring, or season is equal to fall. I could also do this, season is not equal to summer. There's a little bit of an issue there, but we'll get to that. Okay, finally, I'm going to ask the final two questions. If the age is greater than or equal to 13 and the season is summer, then it needs to be 10:30 p.m. Or if the age is greater than or equal to 13 and the season is not summer, then it needs to be 9:30. Okay, we just wrote a whole bunch of code, so let's verify that. Checking the chat here for a minute. Okay, we've got a question from Bethany. Do I need a parentheses around the age argument? And if not, can I explain why? So Bethany, I assume that you were talking about these cases right here where we check the age twice. Is that correct, Bethany?
Correct. Yes, I was just wondering.
Yeah. No, that's fine. So just like if we had a mathematical equation and there were a couple multiplications, the multiplication happens from left to right. So that's what's going to happen here. The and is tied with this and. So we just go from left to right. So age is greater than 5 is the first thing, or these two conditions are evaluated first. Age is greater than 5 and less than or equal to 12. And then, so let's say in the case of 7, that turns into true. And then the next thing, well, the first thing that's compared is this. I misspoke, Bethany, I misled you, I'm sorry. The first thing that happens is inside parentheses. And then we go from left to right. So a set of parentheses doesn't change much for us here, right? To prove that, I'm going to go ahead and run this program with without the parentheses and then with. So we want a 7-year-old in the summer, 9:30 p.m. That's what we were expecting, right? So could add a set of parentheses here. Save my code, reload the web page. 9:30 p.m. Yep.
You
So
have,
this.
but you also have the same bedtime for summer and not summer as 9:30 p.m.
Oh, good call. Good call. Okay. Bad test. That's what happens when we copy paste. Don't be lazy, everybody. Okay. So this one should be 8:30 p.m. Okay. So I'm going to say a 7-year-old in the summer, 9:30 p.m. Add my set of parentheses here. Save, reload, 7 summer, 9:30 p.m. So this set of parentheses doesn't actually change the order of operations, right? This happened first, with or without the parentheses. This happens second, and then finally, this AND operator is evaluated. Does that answer the question, Bethany?
Yeah, it does. Thank you.
Okay. Wonderful. Okay, we've got a little issue here. I'll go ahead and just go over that real quick. So I'm going to reload our page, and I'm going to say I have a 7-year-old in the summer. Uh-oh, I got this case. Why do you think that was? Why did I get this case?
You use the capital for S instead
Yep.
of lowercase.
That's right. I could also type in January here, and I still get 8:30. The reason is we just said it can be any string at all, but not summer, right? So what we probably needed to do was we needed to come in here and be very explicit and say winter, fall, or spring. And then, of course, there are ways to do case-insensitive comparisons in JavaScript. If you care about that, JavaScript case-insensitive compare. And we don't want to look at anywhere except W3 schools on the exam. Yep. Probably your best bet would be to do just take the entire string and there's a function to lowercase. Right, just make all of the input go lowercase, and then you can do safe string comparisons. But okay, finish this off. That should do it for us. When we come back here, 7-year-old in summer, 9:30 p.m. Okay, wonderful. Any questions about this program before we move on to our final topic?
Brother Davidson, maybe another way to express this code, it could be with if, nested if.
Oh, yes. Very, very good point, Gonzalo. For example, we are checking the same condition twice in 3 different instances. So Gonzalo points out that we're checking to see if the age is less than or equal to 5 on line 12 and line 14. We're doing the same age comparison on line 16 and line 18, and then the same age comparison on line 20 and line 22. So we could make these nested if statements, right? And it would look a little something like this. If the age is less than or equal to 5, else if, I'll copy this. Else if age is greater than or equal to 13. Right, then inside of here, we could have other if statements. If the season is equal to summer, then this code will happen. Else, if, well, yeah, that's not quite exactly right. If the season is equal to summer, or season is equal to fall, that. So we've got one if statement, or yeah, we have one if else if statement nested inside of an if statement. So this way, we only repeat the check on age is less than or equal to 5 one time. Anybody have any questions about that?
Nope, it looks great.
Okay. Very good, very good, very good. Okay, our final topic that will be heavily covered on this exam is repetition. Right, so repetition, another way of saying that is loops. I know they're optional assignments this semester, but in previous semesters, the Robbie the Robot assignments were required for every week. And students find themselves having to tell Robbie the Robot to go straight 6 times in a row, and they're like, I don't want to do this. Isn't there a way to repeat statements? And yes, of course there is. Here in chapter 8, weeks 8 and 9, we learn about how you can repeat the same statement over and over again, rather than writing the same statement over and over again. Right, so we've got different types of loops. I think the most important part of this is not pre-test, post-test counting and sentinel controlled loops. I think the most important part is a while loop, a for loop, right? And the do while loop is also an option in JavaScript. It's kind of something that's very specific to JavaScript. The for loop and the while loop, on the other hand, are things that you'll find in many, many other programming languages, right? But the while loop is fairly simple, much like the if statement. It's got a set of parentheses with a Boolean condition on the inside of the parentheses. It's got a set of curly brackets for statements that will be repeated while the condition is true, and it uses the while keyword, right? So we could have a very complicated statement in here. We could have a very simple statement in the condition, the while keyword, and while this condition is true, these statements will be repeated. Okay? The for loop does those same things, it just does them a little differently, right? We use a keyword for. We've still got a condition to evaluate. We've still got a set of parentheses, still have a set of curly braces, and some statements to repeat inside of the curly braces. It just so happens that every while loop, this condition needs to change just slightly, and the for loop gives us a little more control, or it groups together the control statements into one set of parentheses. So we've got three statements inside of this set of parentheses. We've got a variable initialization, or in other words, before the first semicolon, you declare a variable. Many times, every time with a while loop, this condition requires a variable, and probably 6 or 7 lines above, you'll see a variable declared. So initialization or declare a variable. The Boolean condition to check to see if the loop should continue, and an update to a variable that is used in the condition. And then we just have statements to repeat here. Okay, so we are running out of time, but I'm going to come down here to the loops examples, or loops practice programs. And I'm going to force myself to not do one that I think this 12 by 12 multiplication table is safe. Can anybody verify for me if this is one of the examples provided earlier in the course? I think we're safe. Okay, so we want to display a 12 by 12 multiplication table. No inputs really, we just need to click a button, make it happen. So I'm going to come back here. Well, before I do that, oh no, I already copied the program. Perfect. I grab my template, and then I'm going to come back to Visual Studio Code, paste in my template. We don't need an input box, we just need a button. The button should say create table. Okay, so create multiplication table. Create multiplication table. Okay, let's make sure our page is showing up just exactly as we would expect it to. No errors, perfect. Okay, so multiplication table, is anybody not familiar with multiplication tables? I guess I'll just explain that really quickly here. If I needed to make a multiplication table, the table has rows and columns. So along the top, I define columns. Then along the side, I define rows. Okay, so then I could find the intersection of a row and a column, and I could say 1 times 1. I could type the answer right here is 1. 1. 1 times 2 is 2, all the way down to 10 times 1 is 10. 10 times 12 would be 120. Okay, so this is the multiplication table that we need to build. So you can see here, this is probably a pretty good use for loops, right? We need to count to 12, and then for every number between 1 and 12, we need to count to 12 again. So this is kind of leading me to believe that we're going to need some nested loops. So let's go ahead and create those. I will create them with for loops for now, but again, any loop you can write with a for loop, you can write with a while loop. So recall that when we create a for loop, there's 3 parts: variable initialization, and I'm going to call this one column. I'm going to set it to 1, and then I'm going to say while column is less than or equal to 12. That's my Boolean condition to see if I should continue the loop. And then my update statement, I'm going to increase column by 1. All right, and for now, let's just log out the value of column to see that we are in fact getting our 12 numbers. Okay, there we go. So we logged out 1 through 12. Perfect. Okay, so we counted 1 through 12, but for every number between 1 and 12, we need to count to 12 again, right? 1 times 1, 1 times 2, 1 times 3, and so forth. So inside of here, I'm going to create another for loop, and I'm going to say let row is equal to 1, row is less than or equal to 12, and then row plus plus. Okay, now I want to do a console.log, and I'm going to do column separated by a space, and then row. Okay, who can predict the output of this program at this point? First off, how many lines are going to output? Anybody guess? We will output 12 times 12 lines, so I believe that's 144. So I've saved my program. Let's come here, reload, and there we go. A whole bunch of lines. And you can see here we're getting the numbers that we need: 1, 1, 1, 2, 1, 3, and 112, then 2, 1, 2, 2, 2, 3, and so forth. So we've got all the numbers from the row and the column, but now we need to create the multiplication table, right? We need to create the rows and the columns. So let's do that. First off, let's do the multiplication. So I'm going to say let the result equal to column times row. Let's log that out to the console. So here's all the numbers that we expect, from 1 to 144. 1 times 1 is 1. 12 times 12 is 144. So we are getting all of the numbers, but we need to create it as a table. So I think we should create a variable to hold our table, and it needs to be a string. Okay, and then after that, I'm going to console.log the table. So very first, let's just do something like table plus equals result. Let's see where this gets us. It's gonna be messy. Okay. So you can kind of see that this is correct, right? We start with a 1, we have 144 at the end, and then a whole bunch of stuff here in between. So maybe we ought to add some kind of space or delimiter between the numbers. I'm going to do a tab. Let's try that. Okay, that's looking a little better. But this isn't the multiplication table that we want, right? Technically, all of these things are still on the same line. It's just Google Chrome Developer Tools is wrapping them. So we haven't quite created a table yet. I think after every time we finish one of the columns, maybe we ought to add a new line. So let's go ahead and do that. Table plus equals a new line. Okay. Save, reload. There we go. There's our multiplication table. So you can see here, we've got the results. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 12 is 144, and it's very nicely formatted. We are missing some row labels, so maybe I would add something like this. To the very beginning. Oops. and so forth. And then maybe right here, I would say, let's add the row and a tab. Save, reload the program. Let's open Google Chrome Developer Tools, please. There we go. Okay. So we goofed it up a little bit. Let's fix it. Okay. Sorry for the technical difficulties here. Okay, we have 1 through 12, and unfortunately, we have this is the wrong place for this. There we go. No. There we go. Okay, now we have our labels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 times 12 is 144. 12 times 1 is 12. Okay. And I might add another delimiter here. And I might add a delimiter here. There we go. A little better formatting. So we were able to accomplish this with 2 nested loops. Again, we count through 1 through 12, and then for every number that we count on the outer loop, we count to 12 again on the inner loop. We do some multiplication, and we break up the lines. Does anybody have any questions about this program that we just wrote? Okay, my parting suggestion to you is this. On the exam, there are many questions that say, what will the result of this code be? Right? And then it gives you some JavaScript, and then it asks you to type out the answer. It is 100% legal to copy the code from the question, paste it into a program like this, run the program, and see what it outputs, okay? Don't calculate it by hand. It's, you know, you have gained, you weren't given anything, you have gained the ability to become a programmer and to read and run and understand code. So please, when those kinds of questions come up, feel free to run the code, debug it, do whatever you need to do to understand it, but that's the best way to come up with the answer. Okay, and with that, I'll just ask one more time, are there any questions, anything I can cover while we are together as a group? Okay. Well, good luck, everybody. Again, I'll post this recording out to our course, and everybody have a good night.